This video I am going to describe about the application of dimensions and tolerances. The first heading is application of dimension and tolerances. The rules and practices established by a mile STD8A for the application of dimensions and tolerances to drawings provide an excellent guide for the drafter or anyone preparing soft sketches, detailed drawings, etc. The following rules generally agree with those established by the foregoing standard. Number 1 is the thickness and composition of dimensions, extension and center, as well as other lines and specified in MIL STD-1A. Now, number 2, dimensions line are used to show the extent of length, breadth, thickness, etc. to which the dimensions apply. Number 3, the spacing suitable for most drawings is about 3 by 4 inch, that is 0.9 cm between parallel dimensions line or between a dimensions line and the outline of the object. Number 4, extension lines are used to denote locations such as points or surface between which the dimension applies. They are drawn perpendicular to the dimensions lines. However, when required, they may be drawn at an angle provided that their starting point is not questionable. They must start generally about 1 by 16 inches, that is 0.2 cm from the outline of the part 1, extend about 1 by 4 inches, that is in bracket 0.3 cm beyond the outermost dimensions line. Now number 5, all numerals used for dimensioning and all lettering used for dimensions notes must conform to MIL-STD-1A general drawing practice. 6. It is important to provide angle spacing between letters or numerals in order to prevent the becoming blurred when reproduced on a reduced scale. For the same reason, decimal points should be slightly heavier than the Same reason, decimal points should be slightly heavier than the lettering lines and must be properly spaced. Now number 7, all dimensional notes should be placed on the drawings in accordance with MIL-STD-1A. Now 8, it is preferred that the tolerances be placed just to the right of the dimensions and at the same level, but it is permissible to place the tolerances directly beneath the dimensions. The numerals should be placed in a break or the dimensions line, or when the numerals are parallel to the dimension line and written only above the other, the line may pass between them. Now for this I am giving you a figure to see. Line, when limited space requires dimensions to be placed outside the extension line, the dimensions and tolerances may be placed either in line with the dimensions line or above and below its level, and in such case the dimension line should be extended to the dimensions. Now number 10, center lines are used to indicate points and axes of symmetry. They may be extended to show relationship between symmetrical features and also to serve an extension line for dimensional purposes. Number 11, two center lines are drawn at right angles to each other in views showing the contour of a symmetrical feature in order to indicate the center of a circle. The lines have an actual intersection as the center. Number 12. A center line shall be dimensioned when it is used as a reference in locating related holes in or features. Number 13. Leaders composed of straight ruled lines are used for indicate exactly where dimensions and dimensional or indicate exactly where dimensions and dimensions or explanatory notes are to be applied. The node end of the leader is always run either to the beginning or to the end of the node of the dimension, never to the middle. Number 14. Drawings will present a better appearance if the adjacent leaders are drawn parallel. However, leaders should not be parallel to adjacent dimensions or extension lines. Number 15. Leaders drawn to symmetrical features should be in line with the center of the feature, and the arrowhead of the leader should terminate exactly on the line that represents the profile of the feature. Number 16. The unit of measurements on drawings is the inch unless other units are specified indicated, where there is a combination of units of measurements. The units must be expressed accordingly, but where the dimension is in units of inches only, the inch marks may be omitted. Now number 17. Division of the inch are usually expressed in terms of decimals, where it is desired to convert from fractions to decimals. A standard conversion table may be used. Now 18 number. The tolerances on decimal dimensions are expressed in decimals, and the tolerances on fractional dimensions, if used, are expressed in fractions. Number 19. The smallest fractional division used in dimension is 1 by 64, and the smallest tolerance specified by a fraction is 1 by 64. Decimals are used when final divisions must be made. Now number 20. All dimensions expressed in terms of decimals are carried to the same number of places as the required tolerance. For example, use 0.050 minus 0.005. Do not use 0.05 minus 0.005. The cipher is omitted before decimal points. Now number 21. Angles are expressed in units of degrees with division of minutes and seconds, or may be expressed as degrees, minutes, and decimal thereof. Number 22. Angular dimensions and their tolerances should contain the same unit of measurement. For example, use 10 degree 30 minutes 0 seconds equals to 0 plus minus 0 degree 0 minutes 30 seconds, or 10 degree 30 minutes 0 seconds, which is plus minus 0 degree 5 minutes. Do not use 10 degree 30 minutes plus minus 30 degree. It will be noted that this method follows that established for decimal dimensions as previously explained. Now 23. As many dimensions as practical without crowding should be indicated in the principal view. The principal view is the one that most completely shows the characteristic contour of the object. In general, all dimensions for surfaces that show in profile in the view should be given in the view. Dimensions are usually given in the auxiliary views only for those lines or surfaces that are not shown in their true shape in the principal view. Now number 24. In general, crossings of lines used in dimensioning a drawing should be avoided wherever practicable. Now number 25. To avoid crossing the dimensions line for the shortest length is placed nearest the outline of the object, and adjacent parallel dimensions line are added in the order of their size, and the longest dimension line the outermost. This is illustrated in this figure. Number 26. When crossing dimensions lines with extension of leader lines is unavoidable, a break may be made in the extension of leader line at the point of crossing. Now 27. When it is necessary to cross an extension line, it is permissible to break the extension line to improve clarity. Now 28. Care should be taken to avoid crossing leaders, but when crossing is absolutely necessary, a break should be made in one of the leaders at the point of crossing. Now 29. When dimensions are grouped as shown in the figure which I am giving you, clarity is improved by placing dimensions lines and materials in line where space permits. Number 30. Where space is restricted, it is desirable to stagger column of dimensions in 2 or more rows. Now 31. Wherever practicable, dimensions should be placed outside the view. Being this dimension in general, it will be found preferable to place overall dimensions above and to the right of the principal view. Overall dimensions of surface that's shown in profile in two views are preferably placed between these views. Now number 32. The abbreviation DIA may be written after dimensions in order to avoid showing an end view of a cylindrical object as shown in this figure. However, the end view must be drawn if the cylindrical surface includes any special features such as cleavage or flats. Now number 33. The size and location of holes or curved surfaces should be shown in view where they appear as circles of curved unless the abbreviations DIA being used as mentioned before. An exception to this rule occurs where a sectional or side view is taken along the axis of two or more concentric cylindrical surfaces, in which case it usually is clearer and more convenient to show the magnitude of the diameters in the sectional views. Now 34. Dimensions should not be drawn for lines representing hidden surfaces, and dimensions lines should not be drawn directly to the outline of the object. Dimensions should be placed between the extension lines wherever practicable. Now 35. Specific information pertaining to holes is given by means of leader drawn in the view where the hole appears as a circle. This is illustrated in this figure. Now 36. Curved surfaces shown on the shown on arc of circles are dimensioned by drawing a radial dimension line through the origin of the radius to the surface in question. On small radii, the total dimension line may be drawn on the side opposite the center instead of through it. The latter are always follow the dimensions of the radius. The preferred placement of the dimensions for various sizes and types of radii is shown in this figure. On number 37, in specifying the dimensions of a large number of fillets and rounded edges of the same size, it is accessible to specify them in the form of a note instead of dimensioning each individual radius. There are many other radius and practices for the details of complex drawings. However, it is believed that the foregoing list will give the student a great understanding of dimensioning practices. It is now common practice to use all decimal dimensions on drawings rather than fractions. The decimals are easier to use and allow for the small tolerances required for the majority of aircraft parts. Exceptions are made where standard parts such as nuts and bolts have a length and diameter specified as fraction of inches. All drawing practices and specifications including dimensioning are described in the drafting room manual DRM in short, or drafting manual in bracket DM. These are all abbreviation DRM and DM for the company that manufactures the product concerned. There are some variation among different company standard and practices. However, drawings from all aircraft manufacturers are sufficiently well standardized so the technician can interpret them without difficulty. Now, tolerances. Tolerances have been explained to some extent in earlier videos. However, additional information will be given here, including some of the general rules established by MIL-STD-AT. To determine suitable tolerances, it is necessary first to establish the requirements to be imposed on the part involved. The tolerance that can be obtained under normal manufacturing processes and the maximum tolerance that can be allowed without impairing the function of the product. Tolerances should be assigned that are a reasonable compromise between those most desirable for functioning characteristics on the one hand and machining processes on the other. When tolerances are assigned to commercially available stock such as drill, rod, plate and bars, consideration should be given to the commercial tolerances suitable, and if requirements permit, the specific tolerances should not be closer than those commercially available. There are three methods by which the maximum and minimum values of the dimensions may be indicated on a drawing. They are classified as the unilateral tolerance, bilateral tolerance and limit dimensioning methods. In the unilateral method, the tolerances is taken all plus or all minus from an explicitly stated dimensions. The dimensions represent the size of the location that is nearest the critical condition in bracket maximum material conditions, and the tolerance is applied in either a plus or minus directions, but not in both directions, in such a way that the permissible variation in such a or location will be away from the critical condition. This method is illustrated in this figure. In the bilateral method, the dimension indicates the preferred or desired size or location, and the tolerance indicates the permissible variation therefrom. These variations are not necessarily required to be equal in both directions. This method is illustrated in this figure. If variation in size or positions are not more critical in one direction than the other, the mean position or size should be taken for the stated dimensions and equal tolerances assigned for each direction. In the limit dimensioning method, the maximum and minimum permissible values for the dimension are stated specifically to indicate the size or location of the element in question. In the case of location dimensions, the high limit in bracket maximum dimensions is placed above the dimension line, and the low limit, that is in bracket minimum dimension, is placed below the line. In the case of size dimension, the limit representing the maximum material condition is placed above the dimension line, and the line representing the minimum material condition is placed below below the line. So when the limits are specified in the form of a note, the dimension that otherwise would appear above the line precedes the other. The direction in which tolerances are to be taken as indicated by placing at the left or the tolerances one of the symbols plus, minus, or plus, minus. Plus on the upper side, minus on the lower side, placing like that. Now tolerances like dimensions are applied in such a way as to provide all essential information without duplications. All dimensions applied to the drawing except dimensions labeled basic datum, reference maximum or minimum, must have an exact tolerance either applied directly to the dimensions or indicated by means of a general tolerance note, other notes, or referenced associated documents. It is advisable to specify in the general tolerance note the tolerances that are more generally applicable. Now I am giving you the review questions based on the drafting equipment, then drawing views, and lastly this topic what I have discussed now. This is application of dimension and tolerance.